Hello everyone, this is KK Matics, the solution to your mathematics. Today we'll be dealing with the circle theorem. Another circle theorem, we have to talk about what a theorem is, first of all, because it's important to understand what a theorem is. Now, a theorem is actually a general proposition, not self-evident, but proved by chain of reasoning. And in simple put, you can say there are rules that have been proven to be true about circle. Now, let's talk about the various parts of the circle. Now, when we consider the various parts of the circle, this is what this surgeon that you see here now, this line is indicating what the part of the circle that is referred to as arc. Now this is called arc. Arc. It's very important for you to take note of that. And this is what we call our radius. Now from this is the center, the C is the center. So from the center to the circumference or to the circle is what we refer as radius. It's important for you to take note of that. These are important things that you need to know before we talk or delve into circle theorem. Now we have this part. Now the line that divides the circle into two equal halves is what we call the diameter. Now the diameter is actually a line that actually passes through the center. Okay, it passes through the center, so that line is what we call diameter. Okay, now if a line is drawn and it passes through the center, then it's called diameter. Okay, and then we have what we call now, as I said earlier on, that this C is center. So I said that earlier on. Now we have what we call chord. Now this line that you see here is called chord. Now it's very important for you to take note of that. Now a chord can be here. You see, as it shown on your screen there with the pointer. Now it can be here, it can be there. However, well, one thing you need to note here is that the difference between that of a chord and diameter is that the diameter actually passes through the center of a circle to divide a circle into two equal halves, while the chord it just passes through any. It actually divides the, or yes, it divides the line at the circle into some parts. Okay, it's just a part of the circle that, as you see on your screen there, but it doesn't pass through the center of the circle. So that's the difference between the chord and the diameter. Now let's go to some important things here. It's important for us to take note of these things before we talk about the theorems and state the theorems. Now, angles on the straight line add up to 180. It's very important for you to take note of these because with this, these information are helpful when tackling with circle theorem. Now, the second thing to consider is the sum of the angles in a triangle add up to 180. The sum of the angles in a triangle add up to 180 is very important. Okay, so if you have a triangle and okay, so the sum, which means total, okay, which means the addition of all the angles in the triangle, they all add up to 180. The third point to consider here in now is in a section of the triangle, two sides are equal, which also means that two of the angles are equal. Now, whenever we come across dealing with a triangle, we know that with triangle, one of the type of triangle we have is an isosceles triangle. Now, if you come across isosceles triangle, now isosceles triangle are actually angles that have two sides equal. Okay, now if they have two sides equal, it also means they have two angles equal. Very important for you to take note of that. The fourth is that the exterior angle of a triangle is equal to the sum of the interior angle. So the exterior means outside what? Outside that of the triangle. So outside angle of the triangle is equal to the total or the addition of what? The angles in the triangle. Okay, in simple terms. Now, one important thing you need to also note is that in considering this a circle, for instance, if we have a radius there and radius there, it's important for you to know that radius here is the same, what the same length to that. Okay, the radius is the same, so it even tells you that that's isosceles. So just as we said earlier on, the isosceles triangles have what two equal sides, and which also means that two of the angles are equal. So that means that the angle here and there are equal. So the angles are the same. So that's is an example of what I stated earlier on. The next thing for us here is that the first theorem that we have to consider here is, well, not first, okay, it's not in order, but well, it's important for you to, it's important for us to number it. So the first one we'll be dealing with is the angle subtended by the arc and by an arc at the center of the circle is twice the angle subtended by the same arc at the circle. Now it's important for you to take note. Now it's not actually you don't actually need to memorize this, but you could take note of this diagram. Okay, yours is to take note of this diagram. That would be an important thing for you to take note of, because in taking note of this diagram, it helps you a lot. Knowing the diagram is far better than stating this. This is just worse. But this is the important thing here. Illustration here indicates and explains everything better than the words written there. So the illustration that we have here in the circle here, we have so anytime we have a circle with this figure, playing figure in it, one thing you need to consider is that the the angle that is at the center, okay, the angle that is subtended at the center, which is A, is twice the angle that is subtended at the circle or circumference, okay, and so that is A is equal to 2 times B, as you see, and C is the center, okay. So anytime you come across anything like this, always have in mind that your A is what 2 times the B, okay. There is a connection between B and A. Okay, so let's consider an example here. So illustrative example here. So we've been told that we have to find the missing angles in the following circles. Okay, so this is the circle that we have, and obviously this is an example of the theorem just stated. So with this example, we can find the missing value, angle, which is y, and then missing angle of the second question, which is x. So solution here. Now, from the I, we can then compare with this. So comparing this to what we've done here with the first theorem we just stated, we know that A here, okay, we said A equals 2B, okay, so that indicates that so in comparing that, indicates the theorem that we stated. So in comparing that to with what we have here, we can say that our A here is 100 and our B here is a Y. So by stating that, we can then say that, okay, 100 equals what? 2B. Sorry, 100 equals 2Y. And so Y equals 50. Because if we divide, so in finding Y, what we have to do is divide both sides by 2, and we'll have Y to equal to 50 degrees. Now, the second question here is, we notice that we have 30 degrees of the angle subtended at the circumference. And we also notice we have what? X subtended at the center. So that being said, we just use the same formula because it's the same illustration here. So with that, we know that X is what? Twice that of the angle subtended at the circumference, which is 30 degrees. So X equals 2 times 30 degrees, and that gives us 60 degrees. Okay, now theorem 2, important for us to also note, sometimes also called Taylor's theorem, because it was actually um, this was actually named after this man. Okay, the angle subtended on the circle by the diameter is always 90 degrees. So, and I told you, as I said earlier on, it's important for you to take note of the diagram. That's the important thing here. It's not this statement. That's not the important thing. The important thing here is the diagram. Take note of the diagram. Now, in the diagram, we notice that there is a diameter here. Okay, and so this is a triangle, of course, and it has a diameter. Okay, the triangle actually, the base of the triangle is the diameter. So with this, we know that to be center, and this. So the whole idea about this is that this is 90 degrees. Okay, so anytime you have an illustration as this, always have in mind that what the angle subtended at the circumference, okay, from the diameter, okay, is what 90 degrees. So keep that in mind. It's very important for you to keep that in mind than the words stated here. Okay, so let's consider an illustrative example here. So number one, we are told to find the missing angles in the following circles. Yeah, so in considering this example for here, for instance, yeah, we have the center. Obviously, this is what the same illustration to the theorem, the second theorem that we just stated. Now, with this, we are told to find the missing angle, which is y. So if I find the missing angle here, solution, we know angle ABC. Now, ABC, okay, so the angle, now normally we actually, the angle ABC is 90 degrees, so, and that's what the angle that lies at B normally is the middle part, middle letter that indicates the angle that we're referring to. Yes, so that is 90 degrees. So since we have that knowledge in mind, remember, recall that we did state earlier on at the beginning that angles, the sum of angles in a triangle add up to 180. So with that information, we can make use of that information here and find out why. So by stating that sum of angles of a triangle add up to 180. So we know that what the angle of CAB. Now CAB. Now CAA, which indicates what the angle that is what 60 degrees. Okay. Remember I said what the middle letter indicate the angle that we were talking about here. So here we have angle ABC. So the middle angle, which is 90 degrees, yeah, indicates what we're talking about here. BCA, the middle letter here, C, indicating the angle Y. So that's what we're talking about. So, and that equals 180 degrees. So we substitute the angles into, we substitute them, and then in substituting we have 60 degrees plus 90 plus Y equals 180 degrees. So we know 60 plus 90 gives us 150. Yes, gives us 150 degrees. Okay, plus Y. So I was just to make Y the subject, and by making Y the subject, we'll have 180 minus 150 be equal to 30 degrees. So we found our angle here, which is 30 degrees. Theorem 3. If angles in the circle are subtended by the same chord or arc, then the two angles are equal. So with this angle illustration that we have here, always note, as I said earlier on, okay, so it's important for you to have in mind that the illustration is what is important. Know this rather than the words there, because this won't help you. This is what will help you. The illustration here is what will help you here. So if you have an illustration as this, what we are being told is that what we are saying here is that A is equal to B. So yes, the angles on the circle that are subtended by the same chord. So this is a chord, okay, or arc. Then the two angles are equal. Okay, so that's what we are saying. So we are saying this A is equal to B. Let's consider an illustrative example here. Yes, so we need to find the angles A and B in the circle. So you see the illustration, yeah? So this is exactly the same as what this is theorem 3. Okay, so we make use of the information we just received. Okay, so in here, consider the solution, yeah? So we have angle ABD. Now angle ABD. So remember the middle letter, which is B, is what 40 degrees. So that is 40 degrees. And angle BDC. BDC, and that's 50 degrees because what the middle letter is D. So we have 50 degrees here. So by theorem 3, we can then say that what B is equal to what? This B, okay, by this theorem, we know that B equals A. So we can say that B equals what? 40. So B equals what? Angle ABD. It's important for you to illustrate it. Yeah, rather than going straight forward to write B equals 40 and A equals 50, it's very important for you to write what define the angle that you're referring to. Okay, so that being said, we have B to be equal to 40 because what according to theorem 3. Now the next thing here is by theorem 3, obviously we know that A what equals what? Angle A sorry, BDC. So it lies on what the middle letter is still a D. So that means that A equals 50. And we are done with this question here. We move on to, yes, the Y. Sorry, we'll move on to the next one. So theorem 4, angles subtended by equal chords or have the same side. So this is an illustration of what we meant here. So anytime you have an angle, or sorry, a circle, okay, and the angles are subtended by equal chords or acts, then we actually claim that they have the same size. Obviously, we know that this indicates that what they have the same they have the same size here. And since they have the same size, okay, now this actually looks more like a mirror. Okay, this is more like a mirror reflection of what, or the image of or one particular what side. So this A, we're actually saying that A equals B. So as you see there, A equals B. It's very important for you to know here. So let's consider an example here. Yeah, so these are simple examples that we are considering here. So next time we'll merge all of them. Okay, questions are meant to test your understanding. So we'll merge all of them and see, merge all of them and try difficult ones. Okay, so let's deal with these simple ones, trivial ones. Yeah. So let's consider solution. Yeah. So angle ABC. Okay, this is angle A, B, and C. Okay, so we know that the middle letter, which is B, is 40 degrees, and that's what we're written there. Okay, and angle DEF, which is B. Okay, DEF, which is B. Now, so by theorem for what we just said, we know that B equals what? 40. And so that's what they have. Theorem 5. And this is what cyclic quadrilateral. We are saying that if a quadrilateral is cyclic, then the opposite angles are supplementary. So this is what we meant by that. So if so this is a cyclic quadrilateral, but this expression that here we're actually saying that A plus D are supplementary, A plus D are supplementary, that is, that are equal to 180, and C plus B, okay, are equal to 180. So A plus D are equal to 180, and C plus B equals 180, as you see there. So let's consider an illustrative example here. So one, we are to define the angles A and C in the circle. So with this question and diagram we have here, figure we have here, we use what theorem 5 to find this solution. So angle CDA, that is 100 degrees, and angle BCD, and that's 70 degrees. Okay, yeah. So by theorem 5, we know that the sum of ABC plus the angle of CDA equals 180. Substitute the angles, the various variables and values in there. We have A plus 100 equals 180. So making A the subject, we have our answer to be 80 degrees. And considering the other aspect, of course, we're using theorem 5. So angle BAD plus angle BCD, and that's equal to 180. So we have BAD angle BAD, and that's what when you remember the middle letter, which is C. So C plus 70 here, you see there, and that's equals 180 degrees. And so we find our C by what? Taking 70 to the right hand side, and that leads us to what? 110 degrees. And we are done with this example. So move on to the next one there, theorem 6. Under theorem 6 here, we've been told that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to an angle in alternate segments here. So with this illustration we have here, obviously we have our center here in the middle there, very important for us. Now the main thing here, remember the main thing here is the diagram for you to consider here. Now in this illustration that we have here, we are saying that M equals D. So you see the M equals D, and very important for you to take note. Another thing too for you to consider is that yes, from the tangent to the center is 90 degrees. Okay, that's what the tangent, the tangent, okay, from the tangent to the center, okay, the line that's perpendicular from what the center to the tangent is what makes an angle of 90 degrees. It's important for you to take note of that. So this is very important. Let's consider an illustrative example here. Example, we have we are told to find the angle D in a circle. Now, this is what we are given here. So obviously, by theorem 6, we can then say that D equals 50 degrees. Okay, very important for you to take note of the diagram, how it looks. Try and sketch it for yourself. So we move on to theorem 7. Now theorem 7, we are told that two tangents drawn to a circle from the same point outside the circle are equal in length. So as you see on your diagram here, as you see on your screen here, it's important for you to always consider the diagram first. So the diagram is an important thing here. So we are saying that the length here is the same as what? The tangent here is the same as that tangent there. Okay, and the stripe there that you see here indicates that what this is the same as that. And the line that you see here, this imaginary line created here, indicates what? That this is a mirror, that it's a mirror, and it's what? Reflecting what? The other part. Okay, so let's move on by illustrating on that example here. So we totally find the angle x and y in circle. So this is what the figure we given solution here. So by theorem 7, we can then conclude by saying that x equals 50. Obviously, as we said earlier on, this line, imaginary line you see here, is what? It's the mirror that actually reflects what the other side of what this. Okay, so we have x to be equal to 50, then we have y to be equal to 10. And this brings us to the end of part 1 of circle theorem. This is the part 1 of circle theorem. We're expecting the part 2 where we will be tackling with the difficult ones and merging all the properties, all the theorems, and dealing with examples and questions, difficult questions. So this is KK Mathematics, the solution to your mathematics. Please subscribe, like, and share. Bye for now.